Now looking here, we have a Ferris wheel problem here on page 279, question 19, where we first have to write an equation for the height in terms of time. So first, I'm going to visualize this problem as a Ferris wheel being 2 meters above the ground, and with a radius of 10 meters, that also means that our max height is going to be equal to 10 plus 10 plus 2, or in other words, 22. As well, we have a minimum of 2, both in meters. So in order to get d, we're just going to go 22 plus 2 divided by 2, which is equal to 12. We can then go 22 minus 12 to be equal to amplitude, which is equal to 10. So we have d equals 12 and a equals 10. Another thing to note with these Ferris wheel problems, the radius of the Ferris wheel is always going to be amplitude unless it's a really weird question. But typically, amplitude is equal to radius. So our period is 60 seconds. So I'm going to do mine in radians. So I'm going to go 2 pi divided by b is equal to 60, which means 2 pi is equal to 60b, which means b is equal to pi over 30. Now the last thing to figure out is a phase shift. However, the passenger starts at a minimum. Neither our sine or our cos graph starts at a minimum, so you could technically use a sine graph and phase shift it, but for simplicity's sake, the easiest thing to do is just to reflect the cos graph, which means our a value of 10 now becomes negative 10. And now we can write height of time is going to be equal to negative 10 cos bracket pi over 30 times t, and then finally plus 12. So that there is our equation. Now, if Emily is starting at the bottom, what would her height be after 2.3 minutes? First thing to do is to convert this minutes into seconds, because our original equation was done using seconds. So we can simply go 2.3 mins times 60 seconds. And technically with conversion, you would go divided by 1 minute, whatever, cancel, cancel. And what you end up with is 138 seconds. Now what you can do is you can type this as your y1, or you can just simply type this into your calculator where you replace t with 138 seconds. However, for time's sake, we have the h of 138 being roughly equal to 15.09016 which is about 15.1 meters. Okay. And then finally, when will the rider hit 18 meters above the ground in the first cycle? So now I'm going to go over to my graphing calculator and I'm going to input our original h of t as y1. So y1 is equal to h of t, y2 is going to be equal to 18. And so if you do this right, it should appear like this. Like that, because you want to make your window to the first cycle. So your original x min is now going to be 0, your x max is going to be 60, and I made my y min 0 and my y max 30 just for a little bit of simplicity's sake. And now you just find the intersection points. So here, this intersection point is about 21.1449 ... and then of course 18. And then our second intersection is going to be 38.855 ... and then of course 18, which means that in the first cycle, the rider will hit 18 meters first at about 21.14 seconds, and it will then hit it again at 38.86 seconds. So those are our answers about when the rider will hit 18 meters above the ground in only the first cycle. If you're looking for any personalized or one-on-one help, you can check the link below.